Hello friend, welcome to Stack 5, and if you help me to solve today's physics problem till the end of the video, then you get a cookie. So, let's go. नमस्कार दोस्तों, आशा करता हूँ कि आप लोग बहुत बढ़िया है। मेरा नाम है रमेश जमान और मैं आप लोगों का स्वागत करता हूँ मेरे छोटे से चैनल स्टैक 5 में। Oops, sorry, it doesn't sound great, right? Hey, what's up everyone? I hope all of you are doing great. This is Ramesh Zaman and I welcome you all to another good question from wave optics, to be specific, on the subtopic of interference. This question came in JEE Advanced 2017. So let us go through the question very quickly. Two coherent monochromatic point sources S1 and S2 of wavelength 600 nanometers are placed symmetrically on either side of the center of the circle as shown. The sources are separated by a distance 1.8 millimeters. This arrangement produces interference fringes visible as alternate bright and dark spots on the circumference of the circle. The angular separation between two consecutive bright spots is del theta. Because the bright spots are very close to each other, wavelength is very small, right? Which of the following options is or are correct? So let us go through the options first. First, let us check the diagram. So two sources are placed symmetrically here at a distance d apart. Value of d is given, okay, and this angular separation between two consecutive bright spots is del theta. Okay, so we'll get alternate bright dark spots. So these are the options. So a dark spot will be formed at point P2. Where is P2? So for that we need to check the path difference first. P2, the path difference, that is the difference between the rays traveled from S1 and S2, is nothing but d. So at P2, path difference is d equals to 1.8 millimeters, which is fortunately an integral multiple of the wavelength of the light emitted by those two sources. Okay, so according to that it should give you a maxima, that means a bright spot. Hence answer A is option A is wrong, but fortunately at P2 we'll get a maxima, so B is correct. So here we need to put the correct option as B. Now the third option, the total number of fringes produced between P1 and P2 is in the first quadrant is close to 3000. Now here this statement a little bit confusing for me. If I would have given that exam, I might have picked the wrong answer, because the total number of fringes, they haven't mentioned whether it is dark or bright or both fringes. They have just mentioned total number of fringes. So in a generic way I would have understood it as bright and dark combined. Okay, between P1 and P2 in the first quadrant is close to 3000. Now see, here at point P the path difference is 0, so we'll get the 0 order bright fringe. Okay, and here at point P we'll get 3000 bright fringe. In between that there are about 299 dark fringes also. So if you are adding all the fringes, then there should be about 6000 fringes, I guess. 5999 fringes. But I think they are very much interested in the bright spots. Okay, and in their official answer key they have considered bright spots only. So if you consider only the bright fringes, then option C is correct. Okay, but if you consider bright and dark, then option C is wrong according to me. Now which option to take? Again I am saying, if I would have given that exam, I would have skipped option C according to my limited knowledge. But I think examiner have thought about bright fringes, so they have given it as a correct option. So there is a slight dispute over this statement. Anyways, I have rectified the problem which might occur while giving the exam. So the last option, the angular separation between two consecutive bright spot decreases as we move from P1 to P2. Okay, so if you move from P1 to P2, the angular separation between the bright spots decreases. So for the last option, this is the diagram. At any point P, the path difference would be d cos theta. Why? So I have drawn a line coming out from the center at point P. These two sources are very much close to each other, hence these three lines are pretty much parallel to each other. So if this is theta, this will also be theta. Okay, So the path difference between these two waves is this length. Okay, that would be d cos theta. For bright spot condition, d cos theta should be equals to n times lambda, n being an integer. Now as you move from p1 to p2, given according to this our statement, n is increasing. Okay, so dn is positive. Okay, and differentiating both side, minus d sine theta d theta equals to lambda dn. So as you move from p1 to p2, theta is decreasing, sine theta is decreasing, this whole factor is increasing, dn is always positive. Now I am more interested in the magnitude of the angular separation instead of the sign. So the magnitude is increasing actually. Okay, because this whole factor is increasing, so magnitude is also increasing. So option D is wrong because they have told that the angular separation decreases. So option D is wrong, A is also wrong. So according to me, if I was a student, I would have marked only option B, but according to IIT, option B and C both are correct. Okay, I hope you all have found this video helpful and informative. If you are new to this channel, please do subscribe, hit the like button. I'll see you in the next one. Peace, take care. As you have come to the end of the video, you get a cookie. I'll see you in the next one. Peace, take care.